All right, algebra. It is clear to me that after a couple of days, especially in third period, we are still pretty confused about linear functions. So hopefully this video will help you through the homework and help you get a better sense about what's going on. First thing you need to know, linear functions are straight lines when you see them on the graph, and they have constant rates of change. If it's not a straight line, if it doesn't have a constant rate of change, it's not a linear function. If it is a straight line, if it does have a constant rate of change, it is a linear function. Number one thing. Now, we have seen several versions. We've seen tables, graphs, and equations. Let's look at the equation for number one. It's asked, is that equation in standard form? Well, I've got standard form. This was in our notes in class. And I'm just going to highlight the various pieces with color, and it should become really obvious that that equation is not in standard form. All right, I've rewritten the equations, but highlighted x and y. Now just look at both equations. Do those match? Is the x in the right place? Is the y in the right place? Note that the y is on the right-hand side of the equal sign when it should be on the left-hand side of the equal sign. This equation is not in standard form. All right, in number 6, all we're looking for, does this chart have a constant rate of change? Here I increased by 3, here I increased by 5, and now by 7. Here the increase is 9. So is this a constant rate of change? The answer is clearly no. Sure, the y increases only by 1 each time, but the x is increasing first by 3, then by 5, then by 7, and then by 9. The rate of change is increasing, so this is not a linear function. All right. So in number 30 on page 301, we're being asked whether or not this equation is linear, whether or not it's in standard form, and if it is in standard form, what are the values of a, b, and c? Well, I've got the notes over here on the right, and I'll highlight this equation with color. So does this equation match standard form? Well, I have something times x plus something times y equals something. So it does. Look at the purple. Look at the x and y. Since it's in standard form, it's linear, and my values of a, b, and c are easy to identify. Here's number 37. It's hard to look at first, but the question is, can we write it in standard form? If so, we can say it's linear and then identify a, b, and c, the coefficients. To get to standard form, I need to be sure I've got my x's and my y's together on the left side of the equation. So I'll start by subtracting 2y from both sides. Next, I need to get all of the constants alone on the right side of the equation. So I'll add 5 to both sides. I chose this problem because I want you to be able to apply skills you've already learned inside of new contexts. So here's our equation in standard form. Let me highlight the parts for you. At this point, our values of a, b, and c should be obvious. A is 3, b is -1, and c is +1. Now on page 306, I could have asked you to do 2, 3, and 4, because it's really easy to just pick the x and y intercepts off the graph. But we did a lot of that in class. I'd rather you look at number 7. Let's start by putting this in standard form. Subtract 2y from each side and add 3x. You can break that down into 2 separate steps if you want, but the results will be the same. 2y plus 8x equals 16. This is close to standard form, but it's not quite there. Look closely at what happens when I highlight the y and the x. I should have ax plus by equals c. This is better. Standard form is always something times x plus something times y equals some number. Now this is a trick I haven't shown you in class, so I'm going to show you now. To find an x or y intercept, let the opposite variable equal 0. So if we're looking for the y-intercept, we'll let x equal 0. And then we'll solve for y. 8 times 0 is 0, so 2y equals 16, and y equals 2. So the y-intercept then is the point 0.02. To find the x-intercept, we'll let y equal 0. 2 times 0 is 0, leaving 8x equals 16. Divide both sides by 8 and we get x equals 2. The location of the x-intercept then is the point 20. Take the lesson you learned from this problem and see if you can apply it to numbers 21 and 26. And come to class tomorrow prepared with questions about everything we've covered since Monday.